Hey everybody, and welcome back for another remote learning session. It's your boy Mr. D coming at you from home. If you're watching this, you've logged into Google Classroom and are watching this via YouTube. Today what we're going to do is review all of the energy types we've learned about to this point in our energy production unit. We have a quiz coming up next class. And we're going to use some eerily similar images where I'm going to expect you to be able to tell me the types of energy found at each numbered stage in the power plant diagram. So if you go into Google Classroom, you'll see the assignment for today is called Energy Transformation Quiz Practice. What I would do if I were you right now is pause this video and go back and make your best attempt on this assignment. When you're done, come back to the video and watch my tutorial as I go through it and see how you did. It's your chance to self-assess and say, hey, how am I doing on these energy transformations? And am I getting this? Am I ready for the quiz next time? All right, so go ahead and hit pause now. Did you hit pause? Okay, I think you did. All right, now let's get into it. And okay, welcome back. Now you're done with your practice, and here we go. So this first one was our very first energy type we looked at. This could be a variety of different power plants. In our case, this is biomass, right? Down here we've got wood chips, but that could be coal. We could be burning natural gas or oil. Fossil fuels. There's a bunch of different ways we make power here. Number one, that big pile of wood chips we know is loaded with chemical energy. The energy stored in the bonds of molecules. Now, through combustion, we burn those wood chips or oil or natural gas or coal, and we release essentially thermal energy. We convert that stored chemical energy into thermal. Thermal energy is going to be our second form of energy coming out of those flames there. Now, we use that thermal energy to heat this water in the coil and create high-pressure steam. And now we've got high-pressure steam flowing through a pipe over here. And what do you know? High-pressure steam that's flowing really fast is going to have mechanical energy. And we are pretty familiar with this process from here on out. We take our high-pressure steam, we convert that mechanical energy to mechanical energy in a spinning steam turbine, which is hooked up to a generator. That spinning generator is also loaded with mechanical energy, and we know that the whole point of a generator is to convert mechanical energy to electrical. There you go. So there's our first one. In this power plant, we've got chemical energy converted to thermal, and then a few different forms of mechanical, and finally electrical energy being put out to the grid. Oh, let's check out nuclear energy next. This one's got the most conversions out of any other. We've got 7 different types of energy found here. We start deep in the reactor. There's our nuclear fuel, and we know that nuclear fuel, that uranium-235, is actually loaded with nuclear energy, the energy that holds the nucleus of an atom together. We use nuclear fission. Remember the splitting of atoms. We take one atom, we split it into 2, and we fire off a few other neutrons through nuclear fission, and we're going to produce radiant energy. We're going to convert from that nuclear energy to radiant. That's number 2. We're going to use that radiant energy to get the water inside of our reactor really, really hot and convert that radiant energy to thermal. From here on out, the process is identical to a coal-fired power plant or a biomass power plant that we just looked at. We've got superheated water. We get steam really hot, and we allow that steam to flow fast through a pipe, and we yield mechanical energy. That fast-flowing steam spins our steam turbine over here and converts to another example of mechanical energy. That's hooked up to a generator, which is going to take the mechanical energy from the turbine and convert all that mechanical energy into electrical energy. Over here, number 7, heading out those power lines. All right, 2 down, 4 to go here. Oh, everybody's favorite, hydroelectric power. Just 5 energy types in this one. We're going to start way back here in our reservoir. The water up here, as we pointed out back in class, there's water behind the dam up there that wants to be water below the dam down here. That water has the potential to do work, son. And we know that that water is loaded with gravitational energy, the energy of position or place. When we allow that water to flow down through the dam, we convert that gravitational energy into everybody's friend, mechanical energy. And oh boy, looking familiar again, that mechanical energy is transferred to number 3, our turbine. Here we go, mechanical energy in the turbine, hooked up to a generator, which spins around with mechanical energy, and finally converts that mechanical energy to number 5, electrical energy, the end goal of all of these energy production methods. Ooh, on to solar we go. Just 2 forms of energy here, pretty elegant. 1 conversion. Coming down from the sun here, we have energy that travels in waves, 93 million miles in waves, and comes down to us in the form of radiant energy. The cool thing about that solar panel, remember, it takes that radiant energy, it separates protons and electrons. The protons are allowed to flow through this semiconductor layer, and the electrons are forced to go the long way around. And electrons flowing the long way around is a pretty classic example of electrical energy. So just 2 forms of energy there with solar. We start with radiant, we convert it directly to electrical energy, and no moving parts. Good stuff. All right, let's move on to wind energy here. This one's pretty straightforward. Familiar conversions here. We've got number 1. Wind, moving air, has mechanical energy, which is captured by our rotor blades right in here. And we begin to turn our wind turbine. And a spinning wind turbine is going to have mechanical energy. It's going to be converted through the shaft to our generator spinning with mechanical energy. And finally, that generator is going to convert that spinning mechanical energy to electrical energy. Awesome stuff there. Last one. On to geothermal energy. Here we start with hot water way down deep in the earth. And I hear the word hot, I know I must be dealing with thermal energy from deep within the earth. I've got hot water. Here I allow this hot water to flow very fast up through the pipe as steam. We know fast flowing steam has mechanical energy. Notice the similarity here between all these other power plants. The goal in many of these cases is just to get water superheated, make some steam that'll flow under high pressure. Spin a steam turbine over here and again convert to mechanical energy, which is hooked up to my generator, which is going to take my mechanical energy and convert to electrical energy in the grid. Well, there you have it, folks. All 6 energy types. Hopefully, your answers on your worksheet are similar to mine. If not, you can fix them up before submitting your assignment to me via Google Classroom. Make sure you turn that thing in today. I'm looking to see that you went through and practiced. Next class, we're going to take our quiz. It's going to be on Google Forms. It'll pop up next class. That's the only thing we have to do next time. That's March 25th for some of you. And it'll be later for my Maroon Day guys. But next class, yeah, we'll take the quiz. That'll be on Google Forms. That'll be our only thing to do next time. I'm going to post my answer key as well in Google Classroom today, but I'll probably take that answer key down right before the quiz next time. So just know you got plenty of materials to study with. And yeah, looking forward to getting back together with you guys in person real soon. But for now, I really appreciate your hard work during this time of remote learning. Over and out.